Look up! Way, way up! Something amazing is happening high above the desert sands. On September 22, 2025, in a place called Hami, in China's Xinjiang region, a new kind of giant took to the skies. This wasn't a bird or a plane. It was the S-1500, the world's first megawatt-level airborne wind turbine. Picture a massive, graceful airship, like a modern Zeppelin, but with a special job to catch the powerful winds that blow thousands of feet above the ground and turn them into clean electricity for all of us down here. This incredible machine represents a huge leap forward in our quest for renewable energy. The maiden flight of the S-1500 was more than just a test. It was a celebration of science, engineering, and big dreams. A team of brilliant minds from Beijing SA's Energy Technology, Tsinghua University, and the Chinese Academy of Sciences worked together to make this happen. They built this giant right there in the desert, proving it could be assembled anywhere. Then, they watched as it soared into the sky, facing strong winds and passing every test with flying colors. This moment showed the world that we have a new, powerful tool to fight climate change. It's a tool that floats, a power plant that can fly. What makes the S-1500 so special? It's not just its size, which is truly impressive at about 60 meters long and 40 meters tall. It's the idea behind it. For years we have built wind turbines on tall towers rooted in the ground, but the best winds, the ones with the most energy, are much higher than any tower can reach. The S-1500 is designed to go where the power is. It floats up to these high-altitude jet streams, capturing energy that was previously untouchable. This is a whole new frontier for wind power, and it could change everything we thought we knew about generating clean electricity. Think of it as a revolution in the sky. This single event in the Hami Desert marks the beginning of a new chapter for renewable energy. It shows us that innovation can help us solve our planet's biggest challenges. We are no longer limited to the ground. We can now harvest the immense power of the winds high above. The S-1500 is not just a machine, it's a symbol of hope. It's a sign that our future can be powered by cleaner, smarter, and more imaginative technologies. Get ready, because the age of airborne wind energy has officially begun. So how does this giant floating machine actually make electricity? It's a brilliant combination of old ideas and new technology. The main body of the S-1500 is an aerostat, which is a lot like a blimp or an airship. It's filled with helium, a gas that is lighter than air, which allows the entire structure to float and lift itself into the sky without using any energy. This elegant design allows it to climb to altitudes between 500 and 10,000 meters, far higher than any traditional wind turbine could ever hope to reach. It's kind of like sending a fishing net into a part of the ocean teeming with fish no one could get to before. Once it reaches the right altitude, the S-1500 gets to work. The airship is designed with a very clever shape. It has a main airfoil and a circular, or annular wing. Together, these parts form a duct, like a tunnel for the wind. This duct is crucial because it concentrates the airflow, making it faster and more powerful as it passes through the center. Housed inside this wind tunnel are 12 separate turbine generator sets. As the focused wind rushes through, it spins the blades of these turbines, and each one generates electricity, just like a small windmill. It's a team of turbines, all working together inside one big airship. Now, making the electricity is one thing, but how does it get back down to us on Earth? This is where another key piece of engineering comes in, the tether. The S-1500 is connected to a ground station by a super strong, kilometer-long cable. This tether does more than just anchor the airship and keep it from flying away. It's also a high-voltage power line. The electricity generated by the 12 turbines is combined and sent down this special cable to the ground station. From there, the power can be fed into the local electricity grid, powering homes, schools, and hospitals. The tether is the lifeline, the bridge between the sky and the ground. The whole system is designed to be smart and automatic. Onboard sensors constantly monitor wind speed and direction, allowing the S-1500 to adjust its position to capture the most energy possible. It can ascend to higher altitudes when the winds are stronger there, or descend if conditions change. The ground station, meanwhile, manages the entire operation, ensuring everything runs safely and efficiently. It's a complete, self-contained power generation system that floats gracefully in the sky, silently harnessing the immense and unending power of the wind to create clean energy for our world. It's a power plant with a view. When you think of a wind turbine, you probably picture a tall, white tower with 3 long blades spinning slowly in a field or out at sea. These traditional turbines have been wonderful for generating clean energy, but they have their limits. They are massive, heavy structures that require deep concrete foundations and tons of steel to build. The S1500, on the other hand, takes a completely different approach. It's a soft structure, mostly made of fabric and filled with gas. By getting rid of the tower and foundation, it uses about 40% fewer materials. This is a huge deal. It means a lower environmental footprint, and very importantly, lower costs. One of the biggest advantages of the S1500 is its amazing mobility. A traditional wind farm is a permanent installation. Once you build it, it stays there for decades. But what if you need power in a place for only a short time? The S1500 is designed to be a power plant on the go. The entire system can be packed up, transported on trucks, and redeployed in a new location within just a few hours. This makes it perfect for places that are hard to reach or don't need a permanent power solution, like remote mining sites, temporary research stations, or offshore oil fields. It brings power wherever it's needed, whenever it's needed. This mobility and lower material use lead to a major breakthrough: cheaper electricity. Building giant towers and laying deep foundations is expensive. By eliminating these costs, the S1500 is projected to cut the cost of generating electricity by as much as 30% compared to its ground-based cousins. This makes clean energy more affordable and competitive with fossil fuels. It opens up the possibility of bringing renewable power to communities and industries that couldn't afford it before. Making clean energy cheaper is one of the fastest ways to encourage the whole world to adopt it, and the S1500 is leading the charge. Finally, let's think about land use. A traditional wind farm requires a lot of space. While the land can often be used for farming, the visual impact of dozens of towering structures is significant. The S1500 has a much smaller footprint on the ground, requiring only a small station for its tether and controls. The main part of the power plant is floating thousands of feet in the air, mostly out of sight. This allows us to generate large amounts of power without taking up vast stretches of valuable land. It's a more efficient, less intrusive, and more flexible way to harness the wind. Why go to all the trouble of sending a turbine thousands of feet into the air? The answer is simple. That's where the superpower is. The winds near the surface of the Earth, where traditional turbines operate, are often slowed down and made turbulent by hills, buildings, and trees. But as you go higher into the atmosphere, the winds become much stronger, steadier, and more consistent. These high-altitude winds, sometimes called jet streams, are like massive, fast-flowing rivers of air that circle the globe. They contain an incredible amount of kinetic energy, just waiting to be tapped. The relationship between wind speed and energy is truly astounding. It's not a simple linear increase. In fact, the energy in the wind increases exponentially with its speed. A researcher from the Chinese Academy of Sciences, Gong Zeki, explained it perfectly. If you double the wind speed, the energy it carries increases 8-fold. If you triple the speed, you get a mind-boggling 27 times more energy. This is the secret ingredient that makes airborne wind energy so promising. The S1500 is designed to fly right into these high-energy wind streams, capturing vastly more power than a turbine of the same size could ever hope to on the ground. These powerful winds are also much more reliable. On the ground, the wind can be gusty and unpredictable. It might blow hard for an hour and then stop completely, which makes it challenging to provide a steady supply of electricity. High-altitude winds, however, are far more persistent. They blow consistently for much longer periods, day and night, across all seasons. This means an airborne turbine, like the S1500, can generate power more consistently, acting more like a traditional power plant that can run 24/7. This reliability is crucial for building a stable energy grid based on renewable sources. By tapping into this incredible resource, airborne wind turbines unlock a whole new world of clean energy potential. Scientists estimate that the total energy available in high-altitude winds is more than 100 times the entire world's current energy demand. It is perhaps the largest untapped renewable energy source on our planet. Until now, we just didn't have the technology to reach it safely and affordably. The S1500 represents one of the first successful attempts to do just that. It's like discovering a massive, clean-burning fuel source that will never, ever run out. It's a game-changer for our energy future. The magnificent S1500 didn't just appear out of thin air. It is the result of years of hard work, careful planning, and honestly, a step-by-step process of innovation. The journey began with smaller, more manageable prototypes that allowed the engineering team to test their ideas and perfect their designs. Each model was a stepping stone, teaching valuable lessons that paved the way for the next, more ambitious version. This story of development is a classic example of the scientific method in action: build, test, learn, and improve. The first major milestone in this journey was a smaller model known as the S500. In October 2024, the S500 prototype took to the skies over Hubei province in China. This was a crucial first test of the core technology. Filled with helium, the S500 successfully climbed to an altitude of 500 meters, or about 1,640 feet. At that height, it began to generate power, producing over 50 kilowatts of electricity. While this is a modest amount of power, the test was a resounding success. It proved that the aerostat design was stable, that the generators could function in the air, and that electricity could be safely transmitted back to the ground. The S500 was the proof of concept that showed the dream was possible. With the success of the S500, the team moved on to the next, more powerful stage, the S1000. Just a few months later, in January 2025, this new prototype was ready for its test flight. The S1000 was designed to fly higher and produce more power. It climbed to an impressive altitude of 1,000 meters, over 3,000 feet, doubling the height of its predecessor. As expected, the stronger winds at this altitude allowed it to generate significantly more energy. The S1000 successfully produced 100 kilowatts of power, doubling the output of the S500. This test confirmed the fundamental principle of airborne wind: higher is better. These successful tests of the S500 and S1000 provided the engineers with the data and confidence they needed to build their ultimate goal, the megawatt-scale S1500. Each prototype helped them refine the aerodynamics, lighten the generators, and strengthen the tether system. They learned how to manage the system in different weather conditions and how to optimize its performance. By September 2025, after this careful, incremental development process, the team was ready. The S1500, the culmination of all their efforts, was assembled in the Hami Desert and successfully completed its maiden flight, officially ushering in a new era of high-altitude wind power. One of the most inspiring things about the S1500 airborne wind turbine is its ability to bring power to places that have never had reliable electricity. Think about vast remote deserts, isolated islands far out in the ocean, or rugged mountain communities. Building traditional power lines to these areas is often incredibly expensive and difficult, if not impossible. The S1500 changes that. Because it's mobile and can be set up in just a few hours, it can act as a standalone power station, generating clean energy right where it's needed. It can unlock new opportunities for development and improve the quality of life for people in the most remote corners of the globe. This technology is also a powerful tool for disaster response. When a natural disaster like an earthquake, hurricane, or flood strikes, one of the first things to fail is the power grid. This leaves communities in the dark and makes rescue and recovery efforts much harder. Hospitals can't run life-saving equipment, communication systems go down, and people are left without light or heat. The S1500 can be a first responder. It can be transported quickly to a disaster zone and deployed to provide emergency power. This electricity can keep hospital lights on, power radios for communication, and run water pumps, playing a vital role in saving lives. Beyond emergencies and remote communities, the S1500 has many industrial applications. Think of large-scale mining operations or oil and gas fields, which are often located far from established power grids. These industries typically rely on expensive and polluting diesel generators for their electricity. The S1500 offers a cleaner and likely cheaper alternative. It can provide a steady source of renewable energy to power heavy machinery and operational facilities, reducing both costs and carbon emissions. This makes industries that are traditionally heavy polluters a little bit greener, which is a win for everyone. Looking further into the future, the possibilities are even more exciting. Imagine fleets of these airborne turbines floating high above the oceans, forming massive offshore wind farms without the need for building thousands of giant fixed platforms on the seabed. They could also be used to produce green hydrogen, a clean fuel, in remote areas with great wind resources. As the technology continues to develop and costs come down, airborne wind energy could become a key part of our global energy mix, providing clean, affordable, and flexible power for a wide range of needs, from a single remote village to an entire industrial complex. The development of the S1500 is not just a one-off project. It is part of a much larger, long-term vision for clean energy in China. The Chinese government has recognized the immense potential of high-altitude wind power and is actively supporting its development. Years ago, the country's National Development and Reform Commission created a comprehensive action plan for the energy sector. This plan, which runs from 2016 to 2030, specifically highlights the research and development of large-scale, high-altitude wind power as a national priority. This kind of government support is crucial for turning ambitious ideas into reality. This national strategy has created a fertile ground for innovation, encouraging companies like Beijing SAW's energy technology to push the boundaries of what's possible. With clear policy support, the company has been able to attract significant investment to fund its research and development. In fact, SAWS has already completed a third round of financing, showing that investors are confident in the technology's future. The company has also secured orders for its airborne wind turbines worth around 500 million Chinese yuan, which is about $63 million. This is not just an experiment anymore. It's becoming a real business. China's commitment to this technology is driven by its broader goals to combat air pollution and climate change. As the world's largest energy consumer, China is on a massive quest to transition its energy system away from coal and toward cleaner sources like wind, solar, and now, airborne wind. Technologies like the S1500 are seen as a vital part of this transition. They offer a way to generate huge amounts of renewable energy without using up valuable land, which is a major advantage for a densely populated country. It's a strategic move to secure energy independence while also protecting the environment. This strong national backing, combined with academic collaboration from top institutions like Tsinghua University, creates a powerful ecosystem for innovation. It allows for long-term research, risk-taking, and the kind of step-by-step development that led from the S500 to the S1500. China is not just building a new type of wind turbine, it is aiming to become a world leader in this cutting-edge energy sector. By investing in the future of airborne wind, the country is placing a big bet that the sky is the next frontier for clean renewable power. And so far, that bet seems to be paying off. Creating a giant power-generating airship that can live for decades high up in the sky is not an easy task. The engineers behind the S1500 had to solve a number of incredibly difficult challenges to make their vision a reality. One of the biggest hurdles was ensuring flight safety and stability. The turbine has to be able to withstand extreme weather conditions, from powerful wind gusts to lightning storms, all while remaining stable and in its designated airspace. The team developed advanced aerodynamic controls and a robust anchoring system to keep the S1500 safe and secure, even in the toughest conditions. They also established strict no-fly zones to ensure it never interferes with commercial aircraft. Another major challenge was weight. To float, the entire structure, including the turbines and generators, had to be as light as possible. Traditional generators are made of heavy iron and copper. The team had to completely rethink their design, creating ultra-light generators that could produce a lot of power without weighing the airship down. This required breakthroughs in material science and engineering to develop components that were both powerful and lightweight. Every single part of the S1500 was carefully designed to minimize weight while maximizing strength and performance, a delicate balancing act that was crucial to the project's success. Durability was also a huge concern. The S1500 is designed to have an operational life of up to 25 years, just like a traditional power plant. For a floating structure made of advanced fabrics, this is a very long time. It will be exposed to intense ultraviolet radiation from the sun, extreme temperature swings, and constant wind forces. The materials had to be incredibly tough and resistant to degradation. Furthermore, since the aerostat is filled with helium, even the tiniest leak could cause it to lose altitude over time. The engineers had to master techniques for creating perfectly sealed enclosures to prevent any gas from escaping over its long lifespan. Finally, the team had to ensure the entire system could operate reliably and autonomously for long periods without constant human intervention. This meant developing sophisticated software and control systems that could manage everything from power generation to flight control automatically. The system needed to be smart enough to react to changing weather, optimize its own performance, and send alerts if any issues arose. Mastering these challenges, safety, weight, durability, and automation, was the key to transforming the concept of an airborne wind turbine from a futuristic dream into a practical, working reality. The successful flight of the S-1500 is more than just a technological achievement. It's a beacon of hope for our planet. We are living in a critical time, facing the urgent challenge of climate change. To protect our world for future generations, we must find new and better ways to power our lives with clean, renewable energy. The S-1500 and the concept of airborne wind power represent exactly the kind of bold, innovative thinking we need. They show us that the solutions to our biggest problems might be found in places we haven't looked before, in this case, thousands of feet up in the sky. Floating windmills have the potential to fundamentally change our energy landscape. They can access a vast, powerful, and previously untapped source of renewable energy. By being mobile, they can bring power to the most remote and underserved communities on Earth, fostering development and improving lives. By using fewer materials and less land, they offer a more sustainable and less intrusive way to generate electricity. And by promising lower costs, they can accelerate the global transition away from fossil fuels. This isn't just another type of windmill, it's a whole new platform for energy generation. The journey of the S-1500 reminds us of the power of human ingenuity. It shows that when we combine scientific curiosity, determined engineering, and a shared vision for a better future, we can overcome incredible challenges. This project, born from the collaboration of researchers, engineers, and government support in China, provides a powerful model for the world. It encourages us all to dream big and to pursue unconventional ideas in the fight against climate change. Every nation and every scientist can be inspired by this story to push their own boundaries of innovation. As we look to the future, imagine a world where the sky is dotted with these graceful, silent giants, all working together to provide clean power for everyone. A world where energy is not limited by geography, and where our power sources help heal the planet instead of harming it. This is the future that airborne wind turbines like the S-1500 make possible. They are more than just machines. They are a symbol of our ability to innovate our way to a cleaner, brighter, and more sustainable future. The wind is blowing toward a new dawn for energy, and it's happening high above our heads.